space motion is also known as space velocity. It's an object's speed and direction in space as observed from one point. Here we're looking at an object as viewed from the point of the sun. If we draw in the line of sight to the object, and then measure its speed towards or away from the sun, that's known as the radial velocity. If we find the perpendicular speed, that's known as the transverse velocity. First thing you need to find is your line of sight. Then you need to draw the perpendicular in along the line of sight. This is indicating a 90-degree angle. Then you need to find the motion perpendicular to that line of sight, and that's known as your transverse velocity. Now, radial velocity and transverse velocity are vectors, and so they add. So you need to add on the radial velocity and the transverse velocity vectors. So we're going to move the transverse velocity up to the radial velocity, connecting tails to head. The tail of one vector is connected to the head of the other. So let's add on the tail of the transverse velocity to the head of the radial velocity. Then the net we get is from the beginning to the end, and that's what's known as our space velocity. So this object is actually moving in space in the direction of this yellow arrow. And I'm going to indicate that moving away from the observer is positive, and moving to the right relative to the line of sight is also positive. Therefore, this outward and to the right motion is also positive. This is known as the space motion, otherwise known as the space velocity. And as radial velocity and transverse velocity are measured in units of kilometers per second or length per unit time, then our space velocity also has units of length divided by time, such as kilometers per second.